Hey guys, in this video I'll introduce you to the integral test, which is a way of determining if series converge or diverge. Let's say we're given a series with terms a of n, where n goes from 0 to infinity. And a of n is given by some function f of n. So this series is just f of 0 plus f of 1 plus f of 2, and so on. Now we can use the integral test when f of n is positive, decreasing, and continuous. So the graph of f of n might look something like this, for example. Now we look at how we can represent this series visually. We can see that the series is just the sum of all these rectangles as it goes on to infinity, where the bases are all 1, and the heights are f of 0, f of 1, f of 2, and so on. So this series is simply the sum of these rectangles. Now in this case, we can see that these rectangles are always above this graph. So the area or the series would always have a higher sum than this integral if we were going to take the integral from 0 to infinity of f of x dx, just this area under the curve. This tells us that if this integral diverges, then this series must also diverge, because this series is greater than this integral. Now what if we want information about if the series converges? We could shift all these rectangles one space to the left, and we see something like this. Remember, these rectangles continue on. Now we see that the rectangles are always under the graph. So in this case, the sum from, in this case, n equals 1 to infinity would be under the integral of this. So if this function was converging, we know that the series from n equals 1 to infinity would converge as well, since it's under the curve. Then all we have to do to convert it from n equals 1 to infinity to n equals 0 to infinity is just add this first term. So if this whole part was converging, then so would n equals 0 to infinity, because all you would have to do is add this one number. Now keep in mind that the integral test doesn't tell you what the number converges to or what the series converges to, because these values are clearly different. There's just a relationship between them where if one converges, or if f of x converges, so does this, and if this integral diverges, so does this. Now let's take a look at an example. We want to see if 1 over 2 plus 1 over 3 plus 1 over 4 diverges or converges. We can see that this is simply the sum from n equals 2 to infinity of 1 over n. It's important to make sure you check your initial number. N doesn't always have to start at 0 or 1 or anything like that. So it's important to adjust based on what problem you're given. This can be translated into the integral from 2 to infinity of 1 over x dx. When we evaluate it, we see ln of x from 2 to infinity. We know that the limit as x approaches infinity of ln of x diverges. So this function, this integral, diverges, meaning the series also diverges. So if you add 1 over 2 plus 1 over 3 plus 1 over 4 and so on, you don't end at a fixed number. So using the integral test, we were able to see that this series diverges.